Hey folks, it is a Mr. Roach, and this video is brought to you by Flamin' Hot Cheetos. No, they don't actually sponsor me, but maybe one day they'll hear me talking about them and give me free Flamin' Hot Cheetos. It's worth a try. This is a bonus video called the box method. This is a method that we taught last year. We took a little bit more time on this unit last year. We don't quite have that time, so I'm not requiring this in class. It's just another method to factor when A is bigger than 1, and I don't have a greatest common factor to pull out. This is my preferred method, which is why I have Tom Haverford looking like that, because that is how I feel about box method. Makes the most sense to my brain. Do what is best for you. If you prefer the grouping method after watching this, if you prefer brute force after watching this, or if you prefer the box method, just do whatever is the best for you. So I'm going to go through a couple of problems. We'll look at the box method and how it is set up. So the first thing, and probably the most important thing, is kind of the semantics of this and how we represent polynomials within a box. And so the question is, and maybe you could pause and think through this, do you see factored form? Do you see standard form within this rectangle? And it's not super obvious at first, so if you don't, that's okay. I'll explain it in a second. But pause for a moment and see if you can see the two different forms, standard form and factored. I'll do factored in a different color. Let's do that like pinkish color. I like that one. Okay, so hopefully you've paused and given it some thought. If not, that's okay. We'll talk about it. Standard form would be adding up the individual boxes as one equation. So 6x squared plus 15x plus 2x plus 5 would be this standard form equation. It would be smart of us to rewrite this as 6x squared plus 17x plus 5. That's a 5. Just so we can combine like terms. So that's how standard form fits into this. Factored form is a little bit hidden. Factored form is the area written as a length times a width. And I think this is really cool. So what you do is you look at these and say, if I were to write the length and width of this first box, how would 6x squared be split up? Something we talked about before. This could be like 6x and 1x. This could be like 3x and 2x, but you have to pay attention here because this length is also the same as this length, right? So this like first bar down here is going to apply to both of these boxes. So what makes the most sense for 6x squared and 2x? Well, that would be 2x. Same idea. If I'm writing this width right here, that's going to apply to the width of 15x too. So what makes the most sense? That would be 3x for both of those, right? And so this area of this initial box, let me highlight it in purple. 6x squared is broken into 3x and 2x. 3x times 2x would be 6x squared. Now, if we look at the rest of this length down here on the lower right would have to be 5 because that blue 3x times 5 would give us 15x, right? This blue 3x plus 5 would give us, or times 5 would give us 15x. And then up here on the top, this would have to be a positive 1 because the green times my pink would be 2x. And if you notice, oh, look at that, 1 times 5 is also 5. Your factored form of this equation would be your two lengths. So we have 2x plus 5 times 3x plus 1. I really love this because it's so puzzly and you kind of have to critically think through what would make the most sense. Let's look at another example right away here. So I always start in this lower left box negative or 12x squared, and I say, okay, what would this length be right here that would also make sense for negative 9x? I could probably pull out like a 3x from both of those, and sometimes you might get this wrong and you have to adjust, and that's okay. If that is 3x, then this length right here would be 4x, because 4x times 3x would give me 12x squared. And that's looking okay because this 16x could definitely use a 4x in its length and width. If we look at this orange guy now, this is probably plus 4, because 4x times 4, right? 4x times 4 length and width could give you that area of 16x. And that would make this one up top minus 3, because minus 3 times 4 would give us negative 12. So looking at the little tiny areas and making sure it makes sense with everything else, we can double check here. This negative 9x would be your 3x times negative 3. So this all checks out. Standard form, I'll write that out, would be 12x squared. These two would combine to be 7x. And this one would be minus 12. Factored form of this would be the two little groupings that I wrote on the outside as the length and width. 4x minus 3 and 3x plus 4. So let's start a problem from the top, right? Because you're not just going to be given this already set up. The problem's going to look like this, and it's going to say factor 4x squared minus 8x plus 3. And this is how you set up your box. It is so similar to the AC method or the grouping method. A and C are going to go in the bottom left and top right box. So I'm going to put A, I'm actually going to put that whole term there, 4x squared, and C in the top right and bottom left. Now B has to split between these two boxes. Notice how in my other two problems, both of these were regular x's. B has to split between those two boxes, but very similar to the AC method, those two need to add back to negative 8x, and they need to multiply to A times C. So they need to multiply to the same thing as 4x squared times 3. It's pretty much the AC method, just a little bit of a different setup, a little bit of a different way to organize your math. So whatever I put into these two boxes, here and here, need to add back to B and multiply to the same thing as A times C. So what multiplies to 12 but adds to negative 8? That would be negative 2x and negative 6x. You can put these in any order you'd like. Doesn't matter. You'd get the same equation if you flipped them around. And now we solve this cool little puzzle using lengths and widths. If I notice here, I've got a negative 2x and a 4x. Let's make this guy a 2x here. So these two lengths are 2x. This length here would have to also be 2x, because 2x times 2x would give me this 4x squared. Now this yellow length being 2x forces this bottom length to be minus 3. 2x times minus 3 would give me minus 6. Right? And all just kind of like dominoes. It all kind of puzzle pieces fits its way in together. And this bottom guy being negative 3 forces this orange length to be negative 1. And if you double check here, your purple times orange would in fact give you negative 2x. Oh, I love these so much. So my final factored form This boy, written in factored form, would be 2x minus 3 and 2x minus 1. That guy. I think I got one more final example for you here. So let's start from the beginning. I'm going to put A and C into diagonal boxes. And then B is going to split between these two. And however I split it needs to add back to 2x, and it needs to multiply to negative 48. Same exact as A times C. 4 times negative 12 is negative 48. So looking at our diamond problem here, what two numbers multiply to negative 48 add to 2x? That would be positive 8 and negative 6. Again, feel free to put these in any order that you'd like. Don't forget to add your x's there because we're splitting up 2x. So these two terms also need to have x's. So now we complete our little length and width puzzle. Looking at these two lengths. Oh, did I make them purple last time? Nice, go Mr. Roach. This one, I think it makes the most sense to actually make this a 4x. If I make that a 4x, then this one would have to be x. This guy up here, right, 4x times 2 would give me 8x. If, I'll keep this color, if this length is 2 and the area is negative 12, that means this bottom length would have to be minus 6. So if you look here, we've got our factored form equation. X plus 2 times 4x minus 6. Now, you may be saying, Mr. Roach, does this have another answer? Maybe you solved it, and it actually does. So if you want to see that other answer, stick around. If this is like, hey, that's cool, there's my factored form, you can stop, or you can keep going, I guess, and not stop, and see the other version. So if I erase my scratch work here, another option, instead of making this 4x squared, 4 and 1, let's make it a 2x and a 2x, because that would still work. This being a 2x would force this bottom part to be a negative 3. 2x times minus 3 is equal to negative 6. And let me change colors here so it's a little easier to see. This guy being a 2x would force this one to be a 4. So my factored form could also be written as 2x plus 4 and 2x minus 3. If you're saying, Mr. Roach, is there another way to write this one? Yeah, there is. So it would have been better for me to pull out a 2 from everything and simplify this from the beginning. Maybe you were quicker than me and you were able to do that. But really the important thing here is just to show you how to do the box method in different ways, and using, I thought bigger numbers would be more helpful. But yeah, you could actually factor this a third way. The third and final way would be 2 times x plus 2 and 2x minus 3 if you factored out a 2 of everything. So anyway, just a bunch of different examples using the box method. We're able to get in a few. If you enjoy this, give it a try on the homework. If it's confusing and you're like, what in the world did I just watch? Feel free to use some of the other methods. Ask questions. Let me know how I can help. Box method rules. Go Flamin' Hot Cheetos.